Identifying linear functions given ordered pairs. All right, so for this one, they're going to give us 4 different functions per page, and we just have to decide, is it a linear function or is it not a linear function? So I'm going to scroll down here because this example that they give us here works. So they give you the list of coordinates, and then they go ahead and put it in a table. We can actually do it from the list. I'll show you on the next page. But what we want to do is make sure that when we change x, so in this case, they decided to go with -1, and then they did 4 more than that, so they went to 3. 4 more than that, they went to 7. 4 more than that, they went to 11. So it's changing consistently on the left here. We need to make sure it's changing consistently on the right. It doesn't have to change by 4, but it needs to change by the same amount, whatever that amount is. So in this case, we got 0 for the first one, and then when we go to the next one, we went up by 2. The next one goes up by 2 again, and then up by 2. So really, that's what we're going to do on all these. We're just going to make sure that they change consistently, because that means that it's a line. If it doesn't change consistently, then we have different slopes within the line. So the reason we look at that is y has to do with rise, and x has to do with run. So in this case, we can think of it like we have a rise of 2 and a run of 4. So we want the slope to be the same when we go through and do all this. So we just want it to be very consistent when we're doing this. All right, so let's go ahead and start. Oh, I was scrolled down. Silly me. Okay, so I thought my computer was messing up there. So let's go ahead and like I said, we can do this right from the table here. Or the list. We don't need to necessarily create a table. I'll do the x's. So I'll jump from x to x on the top, and then I'll do y's on the bottom here. So I'm going to go from 1 to 4. I have to add 3. So 1 plus 3, that gets me 4. And then from 4 to 7, I have to add another 3. From 7 to 10, I have to add another 3. So I'm consistently changing on the top. On the bottom, I want to make sure that I'm also consistently changing. So now I'm going to switch to y, -1, -4. So in order to go from -1 to -4, I just subtract 3. Because remember, I'm farther negative with -4 than I was with -1. I have to go 3 more negative. And then I'm going to go here. So I have -4 to -9. Well, I'd have to have -5 there. And then to go from 9 to 13, I would go back to 4. So this is not changing consistently. So we would click not linear. All right, let's look at the next one here. I'm going to go back to my red. So we're going to go from -1 to 1. So this is actually +2. In order to get from -1 to 1, I need to add 2. And then I'm going to go to 3. All right, that's add 2 again because I went from 1 to 3. And then 3 to 5, so I'm adding 2 again. So we are changing consistently along the top. And now let's look at the y's. So to get from 3 to 9, I have to add 6. To get from 9 to 27, I have to add quite a bit. I'm going to have to add 18. To get from 27 to 81, I'm going to have to add quite a bit there. Let's see, what does that work out to be? What's 81 minus 27? I was expecting to hear an answer off to the side here, but I didn't get one. All right, 54. So we get 54. So this, again, does not change in a linear way. It's not consistent. And I can test that, too, by putting rise over run. So if I put 2 over 6, I get 3. But if I put 18 over 2, I get 9. So I can see that that's not consistent because I would just divide. 6 divided by 2 gives me 3. 18 divided by 2 gives me 9. So I want these numbers to stay consistent so I get the same, either a fraction or just a single number, single whole number here each time. So let's go ahead and do this on the tables here. So the tables, the same idea. The only difference is we're going to go down one side for the x and down the other side for the y. So for -4, to get to 0, I have to add 4. To get from 0 to 4, I have to add another 4. And to get from 4 to 8, I have to add another 4. So that is consistent. We're going to do the same thing along the side. So to get from 1 to 4, I have to add 3. 4 to 7, I have to add 3. And 7 to 10, I have to add 3. So this one is linear. They're consistent on both sides. Okay, one more. We have 2 plus 1 gets me 3. 3 plus 1, that gets me 4. And then 4 plus 1, that gets me 5. So each time here, I'm adding 1. And then along the right side here, I'm going to add, let's see, 4 for that first one, because 3 plus 4 gets me 7. 7, I'd have to take 2 away to get to 5. And then I'd have to take 2 away again to get to 3. So this is not consistent. I went up by 4, and now I'm going down by 2 each time, so this is not linear. So now we just want to go in here and check our boxes. And check. And we're good to go. All right, clear. Next. Okay, so we're just going to keep doing that same thing. So we have -4 to -1. I'm going to add 3 to do that. -1 to 2. Again, I'm going to add 3. And then 2 to 5. Again, I'm adding 3. All right, so we just need to make sure the bottom here is consistent. So to get from -4 to 0, I have to add 4. To get from 0 to 4, I'm going to add 4. To get from 4 to 8, I'm going to add 4. So that is consistent. So that is linear. All right. Now we're going to do the same thing. So to get from 4 to 7, I'm going to add 3. 7 to 10, I'm going to add 3. And 10 to 13, I'm going to add 3. So now let's check the y's. -1 to 0, to add 1. 0 to 1, I'm adding 1. And then 1 to -4, I have to take away 5 to get back to -4. So that is not consistent. We are not linear on that one. All right. So now let's keep moving here. So we have 2 plus 1, that would get me 3. 3 plus 1, that would get me 4. And 4 plus 1, that would get me 5. Okay, so now we have to get from 3 to -2, I'm going to have to take away 3 and then 2 more. So I'm going to have to take away 5. To get from -2 to -7, I'm going to have to take away -5, or take away 5. And then to get from -7 to -12, I'm also going to have to take away 5 again. So that one is linear. Let me scooch that up just a little bit because that looks like I was checking right in between there. Boom. Okay. One more. So we're going to jump from -5 to -4. So I'm adding 1 because I'm getting my negative went down. So now I'm adding 1 more to get from -4 to -3. And then I'm going to add 1 more to get from -3 to -2. All right. So this one, to get from 4 to 1, I need to take 3 away. To get from 1 to 0, I'm going to take 1 away. And to get from 0 to -2, I'm going to take 2 away. So that's not consistent at all. So we're going to click not linear. So we have linear, not linear, linear, not linear. Check. All right, one more. So to get from 0 to 3, I'm going to add 3. To get from 3 to 6, I'm going to add 3. And to get from 6 to 9, I'm going to add 3. All right. And now from 1 to 2, I'm going to add 1. 2 to 4, I have to add 2. And 4 to 8, I'm going to have to add 4. So that is not consistent at all. It's a pattern, but it's not the pattern we're looking for. So the pattern we're looking for means that they all have to be exactly the same difference. So to get from 3 to 7, I'm going to add 4. To get from 7 to 11, add 4. And 11 to 15, add 4 again. All right. So now I'm going to go from -3 to -8. So that means I have to take 5 away because I'm starting with -3 and I'm going, my negative is getting bigger, which means I have more negative. All right, so -8 to -13. That's another -5. And -13 to -18, it's another 5. So that is consistent. All right, down the side here. So -3 to -2, I have to add 1. -2 to -1, I have to add 1. And -1 to 0, I have to add 1. All right, so then we have 4 to 0. So that means I took 4 away. 0 to -5, I'm taking 5 away. And then 5 to -8, I'm taking 3 away. So this is not consistent, so not linear. All right, last one. So we're going from -1 to 1. So that means I add 2. 1 to 3, I have to add 2 again. And 3 to 5, to add 2 again. All right, now down the right side, we're going from -1 to 4. So we have to add 5. 4 to 9, I have to add 5 again. And then 9 to 7, I have to take 2 away to do that. So that's not consistent again. So not linear. And there aren't necessarily rules on this one. You can get all of them not linear. You could get all of them linear. Or you can get a mix like what we have here. So there's not really any rules on how many you need to get in order to know that it is correct. You just have to check each one. All right, we finished that one.